Assalamualaikum warahmatullahi wabarakatuh. So this is our group assignment for MAT 183. So here I would like to introduce to our group member, which is first Nur Zahira binti Muhammad Hasnan, metric number 2020472502, and the second member is Shadia Rafia binti Hafizi. The metric number is 2020494366, and the third member is Siti Munira binti Cik Ruzairi, metric number 2020612978. In this video, we are going to present the application of differentiation by definition, some problem statement, and solution to the problems. From this video, we are going to understand the uses of differentiation and its rule. In this topic, we are going to explain the chain rule formula. So the meaning of differentiation is a process of finding a function that output the rate of change on one variable with respect to another variable. So here is what the chain rule says, and it tells us how to differentiate composite functions. So when do we apply differentiation? We can use differentiation to determine if a function is increasing or decreasing. So a function is increasing if its derivative is always positive, while a function is decreasing if its derivative is always negative. And what are other applications of differentiation? Growth and decay, integration, the calculus of trigonometric function, the exponential and logarithmic function.
Problem statement 1. The area of a circle is increasing at rate of 6 pi 2 cm square per second. Find the rate of increase of the radius when the radius is 1.5 cm. 6 pi cm square per second is equal to dA per dt, and it was given in the statement. The question wants us to calculate the rate of increase of the radius when the radius is 1.5 cm, that is equal to dr per dt. By applying the chain rule, dA per dt equal to dA per dr multiplied to dr per dt. dA per dr can be found by using the area of circle formula. A equal to pi r times 2. Problem statement 2. Water is flowing out from pipe at rate 7 cm cubic per second into conical tank. The radius of its base is 5 cm and height 10 cm. At what rate is the water level rising when the water is 5 cm deep? 7 cm cubic per second is equal to dV per dt, was given in the statement. The question wants us to calculate the rate of the water level rising when the water is 5 cm deep, or it is equal to dH per dt. dH per dV can be found by using the volume of cone formula. V equal to 1 per 3 pi r times 2 multiplied to h. By applying the chain rule, dH per dt equal to dV per dt multiplied to dH per dV.
For question 1, as the question stated, the area of the circle is increasing at the rate of 6 pi cm square as negative 1, so it is the dA dt, and the r is 1.5 cm. So we have to find the dr dt, and we can find it by multiplying the dA dt with dr dA. So by using the formula area equals to pi r square, we just differentiate the the area, and we will get dA dr equals to 2r square, 2r pi, and we want dr dA, so we will get 1 over 2r pi, and we substitute this number into the dr dt's equals to dA dt multiplied by dr dA, and we will get the final answer is 2 cm as negative 1. From the question 2, we have to find the dH dt, and by multiplying dV dt and dH dV. So from the formula, V equals to 1 over 3 pi r square h. We have to find the r. So from the triangle, we r over h equals to 5 over 10, and we will get r equals to h over 2. So we substitute this into the formula. So V equals to 1 over 12 pi h square. We differentiate the V, and we'll get dV dH equals to pi over 4 h square, and we want dH dV, so it will become 4 over pi h square. So dH dt equals to 7 multiplied by 4 over pi 5 squares. The final answer will be 0.3565 cm as negative 1. For the conclusion for this topic is we have understood how to solve related rates or rate of change that involves geometry formula and function, and we are also able to solve related rate problem using chain rule and implicit method.